This conference will now be recorded.
Yes, good evening everyone. So in today class also we should discuss automata, suffix coding questions only, guys. Okay. Um, See here, whatever the automata fix coding questions we are going to discuss. Okay. So this will not only helpful for you this drive, guys. Okay, that is for DXC. So these coding questions, okay, will be helpful for CTS drive also, guys. So you know about CTS, Cognizant, right? So for Cognizant also, you should face automata fix coding questions, guys. Okay, this will be helpful for you for that drive also. Okay, so that's why all of you, so have a look at this one now. Okay, all of you observe carefully. Okay, and try to answer. So all of you try to give answers. Okay, for each and every coding question. Okay, yes. So today we are going to discuss writing some programs. Okay, for some coding questions we are going to discuss solving errors also, but when compared to solving errors coding questions, we are going to discuss more number of coding questions which we need to write. Okay, so this is the thing, so we are going to cover in today's class, guys. Okay, yes. Observe now. uh, Read this question one more. Let us start discussing these questions more. Okay, observe now. So the following code snippet finds out the last digit of a number entered by the user, guys. So first, suppose if user enters a number 56, so then output will be 6. Okay, so here code snippet accepts single argument num representing the number entered by the user. Okay, you all know this thing, so this is easiest one. Okay, um, just you need to find last digit number. See, observe first of all whether code is correct or not. Okay, so first of all, observe sample input and output specification. 987, from this one last digit is 7. 186, last digit is 6. Okay, yes, observe now. Just it will take 2 minutes time, that's it. Okay, observe now everyone. Here number is entered, and next to that, with the help of this operation, we are trying to retrieve last digit. Okay, so is it correct, ma? Yes, Niharika, good. Num modulus division of 10, a naught, good. G1, good. Good, ma. Yes, a few members given logic here. Okay, very good. So we should use this modulus division operator, right? Okay, so for retrieving last digit, so simply if you change this one, then program will be finished, guys. Okay, that's good. Num modulus division of 10, good, ma. ID number 515. Observe, ma. So corrected code here. So where we corrected? So in this spot, num modulus division of 10. Okay, so just simply if you correct this one, then program will be finished, guys. Okay, so this statement we corrected more as good. Likewise, everyone tried more. Okay, so you can easily answer for it. These are not all problem, guys. So next one is palindrome. Okay, you all know about this palindrome program, right? Might be so many times you observed the same logic, so which we use it for different programs, right? Okay, so now directly I will go for code more. I'll go for displaying code here. Observe 987. So for this input, it should print it is not a palindrome. For what 1001, it should print 1000 is a palindrome number. Okay, yes, I hope so everyone understood this. So let's move to the code, guys. Okay, observe code, everyone. So number is copied into this n1 variable. Okay, whatever the number we take an input, okay, that one is copied into n1, and so it is copied into some variable store also. Okay, afterwards, so until number becomes 0, we keep on repeating this while loop. See here we are retrieving the last digit. Is it correct, ma? So for retrieving the last digit, what we should use? Very good. Num modulus division of 10. Very good. So once again here modulus division operator. Okay. Next ma. So move to the next line now. Ma, observe this line. Next line. Reverse is equals to reverse plus 10 into left. Is it correct, ma? Very good. Reverse is equals to reverse into 10 plus left, right. Okay. So I hope so you all know logic for this one. Reverse is equals to reverse, each and every digit should move to the left hand side, right? Okay. So digit should move to the tens place, hundreds place, thousand place, like this. Okay. So for that sake, so we take like this, guys. Okay. Reverse is equals to reverse plus 10. Okay. And so next of all we add so remainder. Okay. So remainder is stored in this variable, right? Left variable. So that one we should add. Okay. Yes, very good. Here already few members given so logic here for this one. Next line. In this line also error present, ma. In this line error is there. In this line error is there, and in this line also error is there. Okay. Instead of so modulus division, now we should use normal division, ma. Okay. Yes, good. Everyone given correct logic, ma. So next check this one, ma. If condition n1 double is equals to reverse. Yes, it is correct. We take a number value into n1, right? Okay. So it is checking here. I think so. Store is taken, but it is not used anywhere else. Okay. There is no usage. Okay. So although if you do not remove that one, you won't get any problem. Code will be executed. Okay. That's good. So these three corrections, so we should make. Okay. So into this code, observe corrected code, ma, everyone. Now observe corrected code. So these are corrected lines, ma. Okay. So line 1, line 2, and line 3. Okay. These three lines are corrected. Okay. Good. Everyone given correct logic, ma. Good. Next, let us move on to the next one now. Read the next one, ma. The following code snippet converts a binary decimal into decimal number. Okay. Converting binary to decimal, ma. That's it. Okay. So first, suppose if user enters this one 1001. Okay. So what is the output here? Observe. Output will be 9. 1 minute. 1 minute. One minute. Okay, observe. Output is 9, ma. You know this. Okay, this is 2 power 4 position. This is 2 power 0 position. Okay, so on adding 2 power 4 position and 2 power 0 position values, what you'll get 9 here. Okay, simply you know this thing. Already explained this program. Okay, so observe now. Observe input specification and output. Okay, if it is input, so we should print output like this. Okay, that is 17. Okay. We should print both so decimal value and binary value, okay, onto the output screen like this. Okay, so we should print so whatever the value which is entered, and afterwards we should print so decimal value of that. Okay, so for 1001, so we should print 9, guys. For 1001 we should print 9. Okay, that's good. So next, have a look at this one more now. So already given so code for this one. Okay, now the thing is just error correction. That's it. Okay. Yes. So observe, everyone. First of all, number is taken my input, and afterwards so binary value is copied into some num variable. Num value is copied into some binary value, because so you observed in the output specification we should print both binary and next to that so decimal value, right? Okay. Yes, num is equals to num divided by 10. ID number 2 is right. Very good. Yes, error is present in this line. Very good. Here it is so divided by 10. Okay, next. Apart from this, any more errors? Base is equals to base into 10. Base is equals to base into 10. Very good. So here, observe one more error is there. Now we observed so power program, right? So using a power inbuilt function is not allowed. Okay, so that's why we did like this, guys. We taken base value 1, okay, and so we get remainder value, right? So that remainder value, so we are multiplying with so base here, okay. And so next of all, so what we are doing here, so base value we are incrementing here, okay. So we get so like this, guys. Base if you multiply with 2 more, okay, initially, so remainder value multiplies with 1 here, okay. So next of all, on multiplying 1 with 2, what you'll get? 2, okay. Next of all, you'll get 4, okay. Next of all, 8, okay. 8 4 2 1 you'll get. So remainder values you'll get, right? So on dividing this one, 1 0 1 0, let us take this one now as input, okay. So 0 value multiplies with this one, okay. So 1 multiplies with 2, 0 multiplies with 4, finally last so 1 multiplies with 8, right? Like that, okay. That's good. So any more errors apart from this? Check everyone once again. I think so only 2 errors, okay. So only these 2 errors we should correct. That's it. This is modulus division operation only, okay. There is no problem in it. So here we are adding, so with this one more remainder into base, okay. And next of all, we should divide so with 10 more, okay. Afterwards base should be multiplied with 2, okay. Good. You'll get decimal value more, okay, for binary. Good. But decimal, listen here, it is given that converts a binary into decimal. It is not given that it is required, it is not given that to return any value, okay. So we should print values, that's it, decimal value. Okay, fine. Observe my corrected lines here, everyone. So this is the first corrected line and this is the second corrected line, okay. So these two are corrected lines, okay. It's good. Next, 1 minute, let us so observe this one, okay. The function, we should start from here now. Print sequence accepts 3 arguments, okay, n, x and d. First one, an integer representing the starting value of the sequence, okay. See, n represents the starting value of the sequence, okay. Next of all, x represents the number of terms to be printed in the sequence, okay. So x represents the number of terms, and an integer, and d represents, okay, representing a value from so 1 to 10, okay, 1 to 10. So here function method print sequence is supposed to print the first x terms in the following sequence, okay. Next, the sequence contains the integers from n to its next multiple of d repeatedly, okay. N to next multiple of d repeatedly. If n itself divisible by d, okay, then the sequence contains n repeatedly, okay. Your task is to fix the code to so that it passes all the test cases, okay. Let us see input and output specification, okay. So there you can understood very easily. So observe now. See here, n value is 3 ma, okay, x value is 7, okay, d value is 5 ma, okay. So what is n value ma? It is starting value. From that value onwards we should print so sequence, right? So series. And so x is 7. X is 7 means how many values are there in this one? Totally 7 values are there, okay. So this one, the meaning of x is we should print these many number of values, okay. And d is the so stop value, okay. So on reaching to that stop value, so we should stop it, okay. Yes. So number of terms here 3, uh 1 minute. 8 9. Okay. Yes, ma'am. So this one is the stop value, okay. See, we start printing from, so 3, right? So 3 4 5 we print, okay. Next of all, what we do, so on reaching to this so D value, again we should start from the first position, okay. So 3 4 5, okay. So likewise we should print so repeatedly until so we are reaching to these many number of values, okay. So once we print x number of values, we stop, so we're printing values in the series, guys, okay. So we should start from so n variable value, that is 3 here, okay. So next of all we should take so D variable value 5 more. So that is the thing, and observe input specification more. So second one, 282. So n is 2, means the starting value is 2. How many values we should print? Totally 8. Check it, everyone. 2 3 4 5 6 7 8 9. So what is the stop value? So 10, right? Until we are going to reach to this one, we should so repeat, okay. So after reaching to 10, again we start printing from value 2, okay. So if this x value is large, if this x value is large, so after reaching to so 10, once again we start so printing from the starting value, that is 2, okay. Yes. So next, observe this one more. Example input specification 4095, okay. So what is starting value? 40, okay. What is this difference value at 5? So do we can so print up to 5 like this. So this is the smallest value, right? So at that time what you should do, so simply you should print the same value, okay. The same value you should print for so x number of times. Simply the same start value we should print so x number of times when D value is smaller, when D value is smaller than so n, okay. So then what you should do, you should print so start value uh, that is n value, nothing but, okay, n value you should print so for x number of times, okay. So this is series, okay. So in this series already given, okay. So just we need to correct the errors, that's it, okay. Yes, I will explain code first of all of you listen afterwards, so you can go for answering, okay. So no problem in it. So let us check whether it will print all these three outputs or not, okay. Observe everyone. Let us consider first of all so n value 3, okay, x value 7, right? Okay, 7, and next to that 5, okay. So n value is taken into some temp variable, okay. So that is temp value is 3 now, okay. That's good. So counter value starts from 1, so counter less than or is equals to x, counter plus plus, okay. Yes, so these many number of values we should print, right? X many x values. So that's why we take in for loop for x here. And next of all, printf. No problem. Listen, ID number 208. I will explain with the help of this test case. Okay. So with this test case, sorry, with this program, I will explain third test case. Okay. Observe. First of all, observe first test case. First of all, it will print 3. Okay. So after printing 3, observe here. Mario observing this one n. Okay. Next of all, what you should print, listen here, counter value 1 less than or is equals to so 7, right? Okay. Next of all, we should print as a value 4 right here. Very good, Niharika D2, okay. So given logic here, my n is not incrementing here, so n value should be incremented by 1, right? Okay, n value should be incremented by 1. So here error correction is there, okay, so that we can print 4 value, okay. And that too, how we print so n value here you can observe, okay, with the help of this condition, n minus 1 modulus division of t, okay. So that is first of all we print value 3, right? Afterwards we increment it to 4, okay. Next of all we check like this, okay, 4 minus 1 modulus division of so d, what you'll get, double is equals to 0. 3 modulus division of 5, you won't get so result true, okay. So you will get 3 only, right? Means n value will be not updated, okay? So when n value will be updated, so whenever so n value reaches to this value 5 more. So after printing so 5 here, okay, listen, see here n variable value increments to 6, right? 1 minute after printing like this. So 3 4 5, if you we take so plus plus, right, for this one, okay? So here n value increments to 6, okay? So by that time 6 minus 1 means nothing but 5, okay? 5 modulus division of 5, okay? At that time so it is equivalent to 0, right? Okay, so means what happens now n value will be updates. So n value will be updates to, so what is the n variable? 3 7, x value d value is 5, okay? So initially we taken this 3 value into some temporary variable, right? So now that so temporary variable value will assigns to 3, okay, will assigns to n. Means once again what happens, once again it will goes for printing like this, okay? 3 4 5, okay? And so next of all once again it will be repeats, okay, until it is going to so condition in this for loop is going to become false. It will keeps on prints like this, okay? And so one of the student asked for so third test case, okay? I will explain more. Observe now. What was that more? 1 minute, let me check. So that test case first. 40 90 49 5 49 5, okay? So 40 value copies into this one, guys, okay? So temporary variable. Listen, ma, here it will this loop will be repeated for 9 number of times, ma, okay? And so it will print so 40 here, okay? And next of all it will be incremented, ma, by 1, okay? It will be incremented by 1 means so 41. So but observe this one, 41 minus so 1, what happens, ma? 40 modulus division of so this one 5. So you'll get remainder 0, right? Okay, for this one means what happens once again, so n variable so takes value 40, okay? Means so each and every time so it will goes for so printing 40, afterwards it incremented to 41 again, so n value so initializes with 40 more, okay? This procedure will be repeated, okay? So until it is going to end the loop, okay? Understood, ma? Okay, ma, thank you. ID number 20, right? So this is so printing series, ma, okay, with some variable values, okay, n, x, and d, okay. So just we need to make only one correction, right, in this one, okay, that is n plus plus, ma, okay, only this one. I hope everyone understood this. This is corrected code, ma. Observe everyone. So here we corrected, ma, okay, this n plus plus. So that's why if you understood so problem statement first of all clearly, you can easily so design it, okay? So or else you can easily correct the errors here first of all, okay? The thing is understood the problem statement, okay? Yes. Next. Next one. The function or method encrypt unit digit accepts an argument num, okay? An integer value to be encrypted, okay, fine. The function method encrypt unit digit encrypts the unit digit of num by replacing it with the absolute difference between the unit digit and the 10th digit of the num, guys, okay? See here, this unit digit, my unit digit is going to be replaced by So absolute difference between unit digit and the 10th digit. Okay. So with the help of by applying this operation, we are going to observe encryption here. Okay. As one note information is also given here. Value of num is always greater than 9. Okay. If it is greater than 9 only, then only you can observe units place and tens place, right? If we are having just 9 single digit number means we cannot observe both these two position values. Okay. We cannot perform this process simply. So okay, let us see input specifications now. Input and output. Observe sample input and output specification by 893. Okay. So what you should do, you should pick so units place and tens place values. Okay. So next of all, we should subtract these two. Okay. 9 minus 3, what you'll get, guys? 6. Okay. This 6 value should be replaced in the units place. Okay. So here explanation is also given. Observe unit digit is 3, tenth digit is 9. Okay. So absolute difference of these two is 6. Okay. So the unit digit of 893 is replaced with the absolute difference between 9 and 3. Okay. And observe the next input more. So 3 minus 1. Okay. What you'll get, guys? So 2. Okay. So this units place is replaced with the difference here. Okay. I hope so each and everyone understood this one. Okay. It's good. Observe code now. So find corrections. Okay. So first of all, let us take some what was that? 893, right? 893. Take some input more. Okay. See here how we can correct errors means. So evaluate for this one. 893 modulus division of 10. What you'll get more? So 3. You will get unit digit 3. Okay. So here 893 modulus division of 100. Okay. What you'll get more? Modulus division of 100 means 93, right? Okay. 93 modulus division of so 10. What you'll get more? Tell me. You will get 3, right? Again, so here also we are getting so this one only. So unit digit only. We are not getting so 10th digit more. Okay. So how we can do this? 208 num modulus. Yes, very good, Prasanna. 478. So num divided by sorry, num modulus division of 10. So sorry, here divided by 10, right? 93 divided by 10. If you take this one, what happens, ma? So now you'll get so 10th digit, right? Instead of modulus division operator, you should take so this division operator, ma. Okay, we should take this one. Okay. As afterwards, so remaining procedure is so common, guys. And next of all, so absolute unit digit minus 10th digit. There is no problem in it. And observe the next one, ma. So next, see here we get so difference that is 6 ma. Okay, we get difference 6. What we need to do, ma, this one 890 value. So we should add 890. So to be added to this 6, guys. Okay, so that you'll get so 896. Okay, my hopes I understood. 9 minus 3 you'll get 6, right? Okay, ma, this 6 value should be replaced in the units place. Ma. Okay, so for that sake we should take expression like this, ma, 890 plus 6. Okay, so observe this expression ma, now everyone. Last expression. Okay, num modulus division of 10. Okay, so 893 modulus division of so 10. What you'll get, ma? Simply you will get 3. Okay, so 3 into 10, what you'll get? 30. Is it correct? No. Once again, very good, ma. So everyone given so logic here. Once again, it is not correct. So here in place of this one, so we should have so division operator, right? Okay, so now observe, ma. 893 so divided by 10, what you'll get? So 890. Okay, 89 you'll get, I think so, yes. And so 89 if you multiply with so 10. Okay, so you will get 890. Okay, so that 890, so if you add with so this difference, so 6. Okay, so then you'll get so 896, guys. Okay, yes. So here we should so replace these two, okay. So modulus division operators, okay. These two modulus division operators we should replace with normal division operators, okay. Yes, these two. This one and this one, okay. Both these two should be so replaced with so this one more division operator, okay. Yes, observe corrected code, my everyone. Now check it everyone whether it is updated or not. Yes, good. Okay, let us move on to the next one more. So for this one we should write code more from here onwards. So you'll be having coding questions, okay. So observe now. The function print LCM num1 num2 accepts two integers, num1 and num2 as the input. The function is supposed to print the LCM of two integers as the output, okay. See, observe this one. You have to complete the code to make it work, okay. Another function HCF int num1 num2 is available to return the HCF of so two integers, guys, okay, which are supposed to use inside the function print LCM to complete the code. See here how we should calculate LCM by using this function HCF, okay. So directly it is not allowed to calculate LCM, okay. So first of all observe the code, everyone. So 2 3 LCM is 6, okay. 10 20 LCM is 20, okay. So leave it. Observe this one more, okay. Observe this one how we are printing LCM. So first of all we calculate HCF, so that value will be stored in H variable, okay. So into H variable HCF value will be stored, okay. So next of all, so num1 num2 value will be multiplied and divided by H, okay. On dividing so with H with this expression, okay, you will get LCM. How you will get all this I will explain now, okay. So what you should take in this HCF, all these observe now, okay. So this is the basic one. One minute more. So let me open notepad. So in this one I will explain it, okay, clearly. Wait, it was structured here. So I am opening it. 1 minute. Yes, so it is opened. 1 minute. Okay, ma, definitely. So ID number 418. So let us move on slowly. Okay, no problem. Listen, ma. You'll be having so verbal from tomorrow, I think so. Okay. Uh, so your sir will update that information. Okay. Okay, ma, fine. Observe, ma. Let us see this one. Least common multiple, right? Okay. HCF highest common factor. Okay. Let us do one thing more. Let us take some two numbers. Okay. Mm, let us take some 15 and 20. Okay. uh, let us see um, factors for 15 more. Okay, so what are factors for 15 more? So 5 into 3. Okay, what are factors for 20 now? Let us take so 25 or else. Okay, so that you can understood easily. Okay, else 20 also you'll get so common factors, I think so. So just check it once more. Okay, so what factors you'll get more for this one? So 2 into 10, first of all, you should split like this, and next of all, this one 5 into 2. Okay, like this, I think so. This is asthma. So now what is LCM for this one? So LCM is nothing but so union of so factors, right? Okay. So if you found any common factors, you should take only once, guys. Okay. So listen. So 5 into 3 into 2 into 2, or you'll get 5 into 3 15, 15 into 2 30, 13 into 2 60. Okay, so LCM for these two numbers, very good, ma, thank you. Item number 2 is right. So 60. Yes, so you know this thing, right? Okay, listen, ma, now. So you know about so LCM, this is the least common multiple, ma. Okay, so which with which we can divide both these two numbers, ma. Okay, see, observe this 20 and 50, so he is able to divide this number, ma. Okay, so that is the least value. Next to this so previous to this you won't get any value, ma. Okay, so this is the least value. Next of all, next to that you'll get so many values, ma. Okay, with those values, so those values are also divisible with this one. Okay, so 15 and 20, but this is the least common multiple, ma. Okay, so you know this thing. Okay, now let us see the highest common factor, ma. So let us take so this value 20 only. Okay, so now observe, ma. So 5 into 2 into 2. Okay, what is the highest common factor in this one? So both these two more. So 15. So 5 into 3. See here, first of all, you should find out. So for the common factors, okay, listen. Here you are observing this one, right? But these are factors. 5 into 2 are factors of 20. 5 into 3, so these two, 5 and 3 are factors of so 15. Okay. So first of all, you should find factors, okay, of two numbers. After finding so factors of two numbers, you should find so common factor, okay. I hope you understood. First of all, factors, afterwards common factor. Okay, so common factor, so we should take, guys. Okay, might be sometimes you may observe so 2 to 3 values so as common, guys, like this. Okay, I will show you one example here. Okay, observe. So 2 into 3. So next of all, into for another number you can observe like this. Okay, so 5 into, so 7 into 3. Okay, see, observe, we taken factors of these two. Okay, after taking factors of some two numbers, okay, we found that so two factors are common, guys, 5 and 7 and 5 and 7. Okay, among these factors, what you should do, you should pick highest common, highest one, guys. Okay, so for this one, so HCF is 7 more. Okay, HCF is 7. Okay, but 3 is also common, but highest more. ID number 57. See, this one we are observing highest common factor. Now, first of all, we should find factors of two numbers. Okay. After finding factors, we should find the common factor. Okay. So common might be sometimes you can observe 2 to 3. So 2 or more common factors. At that time, what you should do? You should pick the highest common factor. Okay. In these two factors, yes, 5, 7, 3, 5, 7, 3. So three common factors are there. I think so. You are saying that one. Okay, okay, ma. Fine, understood. So in these two, we are observing so three common factors. Sorry, ma. 573 and 573. But in these common factors, which one is highest, ma? 7. Okay. I hope so. You understood how to calculate highest common factor and how to calculate so least common multiple. All these. Okay. So observe, ma, now. Now here one relationship is there, okay. So that relationship so between highest common factor and the least common multiple, let us see now. So for us the same program is given. Why we are discussing only this methodology means, listen, we are having number of methodologies to calculate LCM. Okay, so but in our program it is given that we should calculate least common multiple by using highest common factor only. Okay, so that's why we are discussing this one now. Okay, observe. So this is LCM, and so 5 is HCF. We call this one as a GCD also, greatest common divisor. Okay, so both are same. Okay, HCF or as GCD. Okay, so highest common factor is 5, so LCM is 60, guys. Okay, we are having so one thing, so that is A into B is equals to LCM of A comma B into HCF of A comma B. Okay, we are having one formula. Okay, so for these two, so for calculating LCM and HCF. Okay, so that is you are observing 15 and so 20 value, right? Okay, so for 15 and 20, so we got so this one, right, LCM value of A comma B. Let us take A value as so 15 here, A as 15, so B as 20 now. Okay, so now if you so shuffle this one, okay, my HCF, if you take so to the left hand side, okay, so what happens, now this HCF is in multiplication, right? So on taking this HCF to left hand side, what happens, so it will comes to division, right? Okay, listen, now we are doing this one. We should calculate LCM of so A comma B, right? Okay, so for this one, what you should do, listen, A into B divided by HCF of so A comma B. Okay, yes or no? Now I will share the screen, so all of you observe that one. Okay, now what you observe here, so observe First of all, so calculating HCF, and after calculating HCF, you are observing num1 into num2 divided by HCF value. You are observing this expression, right? We derived this expression. I am showing you. So LCM is equals to num1 into num2 divided by HCF. HCF of num1 and num2. Okay. So on calculating this one, you will get LCM. Okay. Yes. I hope so you understood. 1 minute. I will share the screen. Okay, fine. So here, this is the formula. Okay, this is the formula for calculating. Now let us check what we got. LCM here 60, right? Okay, let us see whether we get so 60 or not with this one or not. Okay, listen. LCM of so 15 comma 20. Let us take this one. Okay, what is A value? 15. So B value is 20. So divided by HCF of A comma B. What is the value, So 5, right? Just now I showed you. So in these two, these are factors of 15. These are factors of 20. Okay. In these two, what is common factor? Highest common factor 5. Okay. So we take this one 5. Okay. So what is the value you'll get? 15 into 20, 300 divided by 5. What you'll get? 60. Check it, everyone. Good money, Harika. Correct. Are we getting result now? So with this one, by in this way also you will get so LCM. Okay. So just if you remember this so formula, you can easily calculate LCM and next to that HCF. Okay. So it is not at all matter, guys. So just you need to remember this thing. That's it. Okay. So here, what is the thing? Already see we are having A and B values. Okay. So we got from the function call. Okay. So now the thing is just we should calculate HCF. How to calculate HCF? I will explain here. All of you listen carefully now. Okay. So we are having one simple methodology here. Okay. With the help of that methodology, with the help of recursion, so we can easily calculate HCF. Okay. Observe everyone. Let us take this one only, 15 and 20. For this 15 and 20, we should get highest common factor 5, right? I will show you that one. Okay. Observe everyone now. Let us see program now. We should write this program. We should type this program. That's why here also I am typing that one. Observe. stdio.h. So int main function. Okay. Let us take some values. A is equals to 15, B is equals to 20. Okay. And let us call some function. Okay. With recursion, right, we should observe. So observe HCF of, okay, so A comma B. Observe. So here we should return some value to this printf, right? So that's why I'm taking return type int. Okay. HCF of int A comma int B. Okay. Observe. See, we are having one procedure here, that is we repeatedly so calculate this expression. Okay. So we apply modulus division of so B with A. Okay. So 20 on applying so modulus division with so 15. Okay. So what you'll get? You'll get result 5, right? I think so. Here itself you understood the logic. Here already we got result. Are you observing this? We got result for HCF. Okay. I am going to use the same thing. So for these type of simple values, you should go for taking program. Okay. So that it will works for remaining types of values also. Observe. Return HCF function call. So I am passing this value okay. B modulus division of so A comma, I am passing this A value here, guys. Okay. So I will explain with the help of comments. So whenever so this A variable value reaches to 0 okay. See now it won't reaches to 0 So now you'll get result 5, right? Okay. So that 5 value I am going to pass to this B variable now. Okay. Into the B variable. So we are going to take the result, guys. Okay. So I hope you understood why we are interchanging this. Okay, see, first of all, on applying this one, b modulus division of a, so you'll get 5 and next to that 15. Okay, so these two will be passes. So now function call starts with 5 and next to that 15. Okay, so next of all, what happens more for the next time? Observe here, 15 modulus division of 5, what will get, guys? 0. Okay, so 0, what is a value now for this function called 5? Okay, so this 5 value we pass, guys. Next of all, we pass 0 and 5. Okay, whenever a value reaches to 0, we should stop this calculating modulus division operation, guys. Okay, so simple, with the help of this expression, I told you modulus division operator is very important one more in so many programs. So circular queue program, we are going to observe this one. Hashing, so concept we are going to observe with this modulus division operator. Okay, this is very important one. Here also you are observing the same thing. With this modulus division, we can easily calculate it. Okay, whenever, so a value reaches to 0, guys. Sorry, a value reaches to 0, so then we return b. Okay, so now for this function call, a value is 0, so what is the return value, so b. Now observe output, my everyone. I hope so understood. Simple, only 2-3 lines, that's it. So I hope you understood why recursion is useful here. Okay, so why we use recursion, so if we can finish so code very easily, okay, it will takes only few lines of code. Okay, so with recursion, so although if you take any type of values, you can finish it off very easily, guys. Okay, so whenever a value becomes 0, we get so b, guys. Okay, simply we perform modulus division. Okay, so with one value and another value. Okay, and so a variable value we are going to copy into b variable. Okay, finally a variable value becomes 0, guys. Okay, so by that time, so it will returns the so b variable value. Okay, so previous modulus division operation result, simply previous modulus division result, so it will be returned. Okay, before going to become 0. Abs output. Abs output, just the thing is, it is required to write these 3 lines. Okay, so if you take this one and return this one, output is 5. Just now only I displayed. I think so. Is it visible now? I displayed just now. Okay, once again I will display, no problem. My highest common factor 5. Okay, fine. On returning this one, see, I explained in the notepad, right? See this one. Listen, we return value for this one, for this function we return value. Okay, so we need to write so this function, that's it. Okay, so to here we return value 5, so that value 5 so will be so divided with this 15 into 20. Okay, so finally you'll get so 60 LCM. Okay, so I will paste this one in the chart box. Okay, so notepad information, and so I will paste that one also. Okay, this one. So if you want to calculate so LCM, you can take like this, guys. Okay, observe here. So printf percentage d comma, so what you should take, guys, a into b, right? Okay, observe a into b divided by HCF of a comma b. Okay, so here you can observe so both these two outputs. Okay, so percentage d backslash n, observe output. 560. 5 is highest common factor, and next to that this one. Okay, LCM is 60. Okay, I will copy and paste this one, so have it. Okay. Okay, fine. I hope so you understood. Just we completed 7 coding questions, I think so. Okay, still we are left over with so many coding questions more. How function with 15 and 20 value? I explained with 15 and 20 only. Right, number 255. But listen, here from this function, we pass at 50 and 20 more, first of all. Okay, observe more. First of all, function call starts with 50 and 20 more. Okay, so it will applies modulus division operation. Okay, 15 20 modulus division of 15. Okay, so what will get 5, right? Okay, so this value and so a value is, so in this function call, what is a value of 15? So that value 15 will be passed to this b variable now. Okay, observe. So 5 comma 15. Next of all, what happens? It will check this condition. No, it is not true. So now what happens? So 15 modulus division of 5. Okay, you will get 0. And so this a variable value will be taken by, so this b variable value. Okay, so next of all, you'll get function call with 0 comma 5. So finally, whenever a value becomes 0, b value 5 more. Okay, that value will be passed to here. Okay, so it is a simple basic program. Okay, HCF. Understood, ma? ID number 255. Okay, ma. Thank you. Fine. Good. Next of all, pattern program is there, ma. Okay. This is the pattern. You all know this pattern, right? Inverted right angle triangle pattern. You observed one sorting program also for this one. Majay, we should write code for this one. Observe. So code is not there. We should write code for this one. If we take so value 5, okay, observe. If you take so input value, that is 5. Okay, we should start so printing values from the 5, guys. Okay, we should print 5s. So if you take so input so 4, okay, we should print all 4s. Okay, understood? If input is 5, we should print all 5s so to the output screen. Okay, in the inverted right angle triangle format. Okay, now what is so we discussed one sorting program. So in this way, so if you have knowledge, if you remember that one, you can easily finish it off. What is that sorting program? Can you tell me? I told you one of the sorting program will works in this format. So that is inverted right angle triangle format. What is that sorting program? Bubble sort. Very good. ID number 25208. Good, more. Bubble sort works in the format of inverted right angle triangle, right? You already know. So logic for bubble sort. It is not at all matter. Okay. So okay, although no problem. So I will type and execute it, mom. So till by that time you also try it. Okay. You people also try to write so code for this one. Okay. I will show you. So code for this one. So we should take so input here. Okay. Int n. So scanf. Already there in the function it is given. Okay. It is not required to take input and all this. So but here I am taking so I am going to show you output for different inputs. Okay. For that sake I am taking so this one. Okay. So next. Already this thing is given, guys. Okay, already it will be present in the backend. So print pattern of some n value. Okay, so we should write this called function part. That's it. Void print pattern int n. Okay, here we should write the code, guys. Okay, in the drives. It is not required to type this part in the examination. They already give you this one, guys. Just we should complete this one. That's it. That's good. So you know this one. So for I is equals to 0, I less than n, okay, I plus plus input. My input is this one ma. So if input value is so like this ma, n value is 4, we should print like this ma, 4 4 4, and so this one 3 fours, 2 fours, 1 4, okay, that's it ma. Observe now. Okay, listen ma. Okay, fine. So observe now. Next of all, for j is equals to 0, so bubble sort will starts from j is equals to 0, right? Ma, here I'm showing this one. Ma, no, I do know this one. Okay, so I showed you inverted right angle triangle pattern. So by in the format of this one. Okay, so j is equals to I. So in that format we observed. Okay, so but here I'm showing you another format. Ma. So by reversing the for loop of I, so or else by interchanging this one, okay. Actually, this is the condition we observed, right, for right angle triangle, okay. My instead of that one, I am showing you another format here. Already we discussed that one, right? In the patterns, we discussed it inverted right angle triangle in that format. Here I am showing third format, okay. So first one, so first format is reversing for loop of I. So next, so this one is reversing this j loop I, okay, taking I here. Okay, so in the initialization part, in that way also we can print it. Here I am showing you another way. Observe everyone. So n minus I minus 1, okay, so I plus plus printf percentage d comma n. Next printf, oh sorry I j plus plus, right, sorry, thank you. Printf backslash n, okay. 1 minute. Let us check so with comments guys now, okay. So what is going to be happened? So let us take some basic value, that is 2, okay. So this one will be repeated for how many number of times more? So 0 1, okay. This one will be repeated for 2 number of times, okay. So we do want that one only, okay. Must see if you take so value 4, it will be repeated for so 4 times, okay. So there is no problem in it. After writing code, we should check like this, okay. So j value starts from 0, okay, and so let us check this one guys, okay. 0 less than n minus I, 2 minus 0, 2 minus 1 1, okay. So means it will compares only for the one time, okay. Are you observing this one? So only 1 2 will be printed in the first row, okay, and so it won't prints the next one. So for that sake, so let us do one thing guys, okay. And so if you take like this guys, so 3, you can understood one thing here, okay. So first time it will take 0 2, 0 less than 2, okay. By the next time, if I value is 1, okay, so by that time it will takes like this guys, okay. 3 minus 1 2, 2 minus 1 1, okay. Means it will performs only one comparison, okay. Means here you'll get problem, right. So that's why here the last value is not printing here, okay, in each and every iteration. So for that sake, I will do one thing guys. So I will take so percentage d backslash n here, okay. So you can observe now. So take this 2 more. First of all, 0th iteration, okay. So for 0th iteration, so it will checks like this: 2 minus I 0, 2 minus 0, and 2 minus 1, you'll get 1 here, okay. 0 less than 1, it will print so 2. Next of all, 1 less than 1, condition becomes false, okay. So what happens, it will comes outside and it will print so value 2, and it will move to the next line. Means what it prints now, 2 2, it will print 2 2, and it will move to the next line. So next of all, What is the I value, guys? So 1. Okay, and observe now. So J value again starts from 0 now. So but 2 minus so 1, what you will get, guys? 1. Next 1 minus 1, 0. 0 less than 0, false. Okay, so directly it will comes to outside, it will print 2, means that 2 prints in the next line. Okay, see, if you check for these type of basic inputs, so it will works for remaining things also, guys. Okay, so actually what we observed, this is a bubble sort program, right? We taken bubble sort program simply. Okay, and we found one thing, actually, so in each and every iteration, so what it is printing less than one value. In each and every iteration, it is printing less than one value because of taking this one. In the bubble sort also you observe the same thing. Okay, one iteration will be reduced, right? So first for getting a correct output, we are taking so percent LD outside, guys. Okay, that's it. Already you have program. So for this one, inverted right angle triangle. So here I am showing you another one. That's it. Okay. Sorry, I and j has to be declared. Int I j. Okay, let us see output at once. Let us enter 4. Okay, observe output 4 fours, 3 fours, 2 fours, 1 4. Okay, yes, we are getting so correct output here. You can check for any type of input specification. Okay, so you'll get the correct answer for this one. So here this is another way. Okay, so I will show you for another output specification, that is 5, right? 5. Observe output 5 fives in the first line, 4 fives, 3 fives, 2 fives, and 1 5. Okay, so this is different code, right? So for inverted right angle triangle, that's why I told you, you will be not having only one way to write any code. So you can write in so same code in number of ways. Okay, so I will give you this one. So check it once, everyone. Okay, understood, everyone? Observe output specification, whether we are getting so same output or not, you can check it. Okay, so just by so taking some sample input, you can check whether your code is correct or not. Okay, based on that you can make some modifications. Okay, that's it, so that it will be finished. That's good. So thank you, ID number 518486. Okay, so good. Next, decimal to binary. Okay, I showed you this code also, right? Okay, but here you are going to observe in different format. Okay, the same codes again you are going to observe in different format. Okay, so I think so nearly 1 hour completed. Just take some small break. Okay, so for 5 minutes afterwards, let us discuss the next coding question. Okay, remaining coding questions. Okay, fine. Okay, come back everyone, guys. Okay, ID number 2A1. So I will share this PDF more, and so ID number 418. So definitely I'll discuss programming MCQs also more, but for me, so only the thing is they asked me to discuss only automata fix coding questions only. Okay, so that's why I'm discussing this one. So if all you people so keep some request, okay, so to that so company or else to your college management, okay, so then if they allow, okay, so then definitely I will discuss now. Actually I'm having so many MCQs, okay, pseudocode MCQs, programming MCQs, all these are there with me, okay, so related to the previous so years, so but so you should take permission of so them, okay, then only I can discuss more. So directly I cannot take any initiative more, okay, so it is not there in my hands, okay. So for suppose in today's class if we finish this one, so definitely let us discuss so programming MCQs also, okay. Yes, fine. Okay ma, fine, thank you ma. Okay ma, definitely I'll share it ma. Tell. Fine. Decimal to binary. So directly let us see this one more. So yesterday I explained this program also, okay. So 5, so on converting to binary you'll get 101, 9 on converting to binary you'll get so 101001, okay. That's good. Let us see the program more. So writing program is not required, just error correction only, okay. Observe everyone. So let us take so value so 5. What is the input specification we observe more? So 5, right? Yes. Let us take that one. So observe here, we taken this one more recursive function call. Okay. So 5 greater than 0. So true. If it is true, so it will goes for executing this one. Okay. 5 modulus division of 2. What you'll get more? You'll get 1, right? So that one value, so function will starts with value 1 more. Okay. Next of all, once again it comes to this recursive function call. Okay. So 1 modulus division of 2, what you'll get? 1 only. Okay. 1 modulus division of 1, 1. Okay. So once again it will comes to here. Will it stops recursion? Are you observing here? So we are getting so we get this error, maximum recursion depth exceeded. Okay. So by storing all these 1 1 1 1, okay, so whenever actually you will get so this thing, okay, so value less than 0, are you observing this if condition ma? Whenever you will get 0 or else less than 0, okay, then only condition will becomes false, right? We are not getting 0 here, okay. So now here modulus division is not correct ma, so you can easily understood here, okay. So here instead of modulus division, so we should take a normal division operator, okay. So here instead of modulus division, so we should take normal division, okay. Very good. 208 n divided by 2. Now let us execute so for n divided by 2 ma, 5 divided by 2, what will get? So 2. Next you should take one stack data structure ma, like this, okay. Into stack data structure all these so function calls will be stored, okay. So first of all function call stores with so value 5, guys, okay. Yes. So next of all so function call so with value 2, guys, okay. Condition checks here, so this is true. So now what happens, guys? 2 divided by 2, you'll get so 1, okay. So next of all function call starts with value 1, guys, okay. So that one will be stored here in the recursion. So 1 greater than 0, again it is true, okay. So true, condition is true. So 1 divided by 2, you will get 0. So whenever you'll get so 0, okay, so then it will stop the recursion, guys, okay. So then it will stop the recursion. Observe here. So what is there here ma? Printf, so percentage d n divided by 2 is there, okay. So observe ma. So n divided by 2 means so what is the n value we got, guys, okay. Listen, first of all we got so 5. 5 divided by 2 means you'll get 2. Next of all we got 2. 2 divided by 2 means you'll get 1, okay. We should fetch all these function calls, okay. First of all, we should fetch this value 1. This printf statement is applicable for each and every recursive function call. For this value 1, value 2, value 5, you should apply printf now. First of all, you should fetch so 1 outside, okay. So after fetching 1 outside, 1 divided by 2, you'll get so 0, not this one. First of all, you should start from topmost position, right? 0, okay. Next of all, you should fetch so value 2. 2 divided by 2, 1, okay. Next of all, 5 divided by 2, you will get 2. Is it correct, ma? Is it binary value? No. So it is not correct. So instead of so this normal division, what you should take, ma? Normal division is not correct here. Yes, ma. Modulus division. N modulus division of so 2. Here we should take n modulus division of 2, ma. Now we observe, ma. So first of all, we retrieve value 1 right from this function call. So 1 modulus division of 2, 1, okay. 2 modulus division of so 2, 0, okay. 5 modulus division of 2, 1. So observe whether we are getting correct result or not. 1 0 1, okay. Means just you should interchange. So in place of modulus division we should take normal division, and in place of normal division we should take modulus division, okay. So if you interchange this one, you can complete this one. Observe how easily we are calculating with this recursion now. I hope you understood what is the usage of recursion, okay. We discussed the disadvantages, okay, of recursion. So with we compared with iterative approach and we compared with the dynamic programming approach, but I said one thing. So we are having so many usages with this one, okay. So recursion, with the help of this one we can finish code very easily, guys, okay. Yes. So observe the corrected code, my everyone. Now observe. So just we made so 2 changes now, okay. This is the first line we changed it, okay, and this is the second line we changed it, okay. Yes. Good. Next, let us move on to the next one more. Get ones count. So accepts an integer n as the input. The function is supposed to return the counts of ones in the binary representation of 1, okay. Means for suppose let us take this one, okay, 1 0 1 0, okay. So we should take input as 10, okay. For this 10, so we get binary value, right? First of all, we should calculate binary value. After calculating binary value, we should calculate so number of ones, okay. So count of ones, that is 2, okay. 1 minute. Okay, ma. So it's an important call, ma. Urgent call it is. Sorry. So observe everyone. So I will explain once again, ma. Observe this. Okay, 101. Okay, how many so ones are there, ma? 2. Okay, let us take so this one 9. Okay, so 1001. Okay, once again, how many ones, ma? 2. Okay, so simply you should find this one, ma. Okay, that's it. I hope so you understood. So this one problem statement here. Now observe, ma. I'll explain the code. So count value is taken. So from 1 ma here. Okay, observe, count value is taken 1, n value, let us take some value 5. Okay, so 5 greater than 0, so as true it is. Okay, so if it is true, what happens now? Observe, 5 divided by 2 is equals to 1. Okay, uh yes, so you'll get 1, right? At that time count increments to 2. Okay, next of all, n modulus division of 2. First of all, trace like this. Okay, you will understood what is the problem in this one. Okay, so 5 modulus division of 2, what you'll get? 1. Okay, so 1 greater than 0, so once again so condition is true here. Okay, so next of all, what happens? 1 divided by 2, so you will get result 0 here. Okay, so you won't get so correct result, guys. Okay, for this one you'll get count to 2 only. So but if you observe for remaining things more, so you won't get correct one. So let us check for value 9 now. Let us check for value 9. So 9 divided by 2, double is equals to 1. Okay, so 2 into 4, so you'll get 4, right? No, so it will be not incremented. Okay, so afterwards so you'll get 1 here. Okay, so 1 greater than 0. Okay, 1 divided by 2, not, so you won't get correct output here simply. So this is not correct one. So what you should do, you should make corrections now. See here it is not correct, not normal division, it is modulus division. Okay, yes, so you should take modulus division here. Now let us take value 5. Okay, here in place of modulus division we should take normal division. Okay, this one is so modulus division. Okay, and so this one is normal division. So 5 divided by 5 modulus division of so 2, you'll get so remainder 1, right? So it is true, so you'll get true for this one. Count increments to 2. Okay, so next of all so 5 divided by 2 ma here. So 5 divided by 2 means you'll get 1. 1 greater than 0, true. So if it is true, so it will checks like this. Okay, so 1 modulus division of 2, you'll get 1, right? Once again. Okay, so 1 modulus division of 2 means you'll get 1. So this one is also true. Okay, means count increments to 3 now. So earlier it was incremented 5 modulus division of 2, true. Okay, so by that time it increments to 2. Okay, now it increments to 3. Okay, so what is the value we should take, guys, now for count variable? Tell me. Not only this, so modulus division and normal division, we should make one more change. Very good, id number 254. Okay, so we should take so count value 0 ma. Okay, we should take count value 0. Okay, yes, very good. If we make these three changes, so then you'll get so correct output. Okay, observe code everyone, corrected one. So count value 0, n modulus division of 2, double is equals to 1, n is equals to n divided by 2. Okay, so if we make these three changes, then you'll get correct one, guys. Okay, yes, good. Next. So this one, for this one we should so write program. Observe everyone. First of all, I will explain this one. So same position bit count accepts two integers, so n1 and n2. Okay, and so function is supposed to print the count of bits which are equal in both the integers at the same positions. Okay, see, let us understood, all of you try to understood with this sample input and output. Okay, so let us take 5 and 6 more. Okay, so what is binary form of so 5 more? 101. Okay, what is binary form of 6? So 1 0 so 4, this one, right? 1 minute more. Yes, more. 1 minute. 1 0 1. Okay, So this one 1 1 0, okay, but this one is 5, and so this one is 6 guys, okay, this one is 6. 2 power 0 bit, 2 power first bit, so 2 power 2 bit guys, 2 square 2 power 1. On adding these two you'll get 6, okay. So now observe how many bits are so common ma here in these two. Same position bit count ma, that too, okay, same position. So these two positions having the same bit, right, okay. So that's why you should return so 1 here, okay. I hope so you understood problem statement. Observe problem statement once again. Accepts two integers n1 and n2 as the input. The function is supposed to return the count of bits which are equal in both the integers at the same positions. Okay, yes. For this one, so code is not given. So just function is given like this. Okay, into same position bit count. So this function takes two variables n1 and n2. Okay, so we need to so return. So how many bits are common, how many bits in the same position are common of these two numbers in binary form, okay. So observe everyone guys, okay. Now simple one more, you can easily finish it off. Observe everyone. So we should take two values, right, n1 and n2, okay. So we should take so input for so 2 n1 and so n2, okay. We should call function like this, okay. Same position bit count, okay. So n1 comma n2, okay. Observe now. Int, so we should take so function within printf, right, percentage d comma, okay. The same position bit count, okay. So it should take so two values guys, n1 and next to that n2, okay. Observe now everyone. So simply we do one thing guys, okay. Let us take so values 5 and 6, right. For this input specification only we should observe, okay. So I will give you one small so logic here. Observe. So we divide so 5 with so 2 more, okay. So what you'll get 1, right. Next of all 6 we divide with the 2, okay. So what you'll get 0, okay. So these two are not matching, right. So 5 modulus division of 2, 6 modulus division of 2, results are not matching, okay. So if these are not matching, so we move to the next value guys. 5 divided by 2 1, simple again with modulus division and normal division you'll get so result here guys. 6 divided by 2 so 3, sorry, 5 divided by 2 2, 6 divided by 2 3, okay. So now once again so we should check for these values guys. 2 modulus division of 2 so 0, 3 modulus division of 2 you'll get 1 again. So these position bits are not matching. Are you observing how we get bit positions simply by applying modulus division operation only, right. Observe. So now what we'll do once again so we reduced value guys, okay, with the help of so division by 2. 2 divided by 2 you'll get 1, okay. So next of all so this one guys 3 divided by 2 you'll get so 1, okay. So now observe here 1 modulus division of 2 you'll get 1, 1 modulus division of 2 you'll get 1, okay. At that time so we should increment so count by 1 guys, okay. I hope I understood, okay. Yes, simple. So with this until n value is going to become 0 guys, okay. So next of all so if you divide this one, so 1 divided by 2 you'll get 0. Next of all so 1 divided by 2 you'll get 0 until these two values so becoming 0. We should keep on repeating this one, okay. If any one of these two values becomes 0 we should stop it guys, okay. So it is not required to apply. Listen first of all we should take so count variable right to 0, okay. Next of all this condition so n1 greater than 0 or n2 greater than 0, okay, until n value and n2 value becoming 0. We should keep on repeating this one, okay. So simply you should check like this, guys. N1 modulus division of 2 double is equals to N2 modulus division of 2. Okay. So whenever the modulus division result of these two will be so equal, okay, so then we should go for applying this one. You can take any value, guys, okay, not only this one. So let us take value 8 and next to that 12, 8 and 12. So these two matches at 8th position, right? 8th position. So these two values in the binary form matches, okay. So at that time, so we increment counter by 1, okay. So simply we do process like this, guys. Observe now. So we increment so count value by 1, guys, and next of all afterwards we should reduce so n1 is equals to n1 divided by 2, n2 is equals to n2 divided by 2 for checking the remaining values, okay. Yes, so finally we should return count. That's it. I hope so each and everyone understood this one, okay. Now this is a program for same position bit count, okay. Observe output ma. Let us check so this one, guys, okay. So 5 6, so what is the result we are getting? 1. So any of you tell me some other inputs ma. Let me check for so some other inputs. Any two values? 7 8. Okay, very good. 10 15. Okay ma, 1 minute, let me check for 7 and 8. Okay, 7 and 8, no bit so matches, guys. 8 means so 2 power 3 position bit sets to 1, right ma? No, let us check this one. 2 15. So 10 15. Very good. 10 15, 2 bit positions matches, okay. So what are those bits, guys? So 10 means how you will get on combining 8 and 2, okay. So how you will get so 15 now, then so on setting all bits so 2 power cube, 2 power 3, 2 power 2, 2 power 1, 2 power 0, on setting all these bits so you'll get this thing, okay. That's more fine. You check with the different inputs. I will give you code, okay. So it is not again so we are not having enough time, okay. So you check with so different inputs, okay. Fine. So I hope so each and everyone understood this one now. This program, same position bit count. Okay, so let us move on to the next one. It is simple program, okay. So just you need to make so corrections only in this one. You can finish it off within 2 minutes. So read this program, everyone. So this function check divisibility accepts two integers, a and b, as input, okay. The function is supposed to return the quotient of a is divisible by b. That's it. Else the function is supposed to return 0, okay. If so a is divisible with so b, okay, so then we should return so 0, guys, okay. So then we should return the quotient if a is divisible by b, okay. So otherwise we should return so 0, okay. Observe now. So 24 modulus division of 6, okay. So we get result 0, right, on applying modulus divisions. So 24 is divisible with 6, okay. If it is divisible with 6, so then what you should do, guys? You should check like this, okay. First of all, you should check whether so 24 so is divisible with 6 or not, okay. Is divisible with so 6 or not. If it is divisible, so then you should return so 24 by 6 value, okay. 24 by 6 value, what is this one of 4, okay. So now check the next one more. So 10 and 0, okay. So for this one you should take return 0 more, not no, okay, not no. So 10 divided by so modulus division of 0, this is not possible, okay. So at that time you should return 0 guys. Okay, that's good. Now observe my everyone. So you are observing the same thing now. Okay, in the first line, if b value itself we got 0, that is denominator value is 0, so it is not required to check anything more, so directly you can return 0. Okay, so next, otherwise, so if you should check like this guys. Okay, if a is divisible with b, so then what you should do more, we should return so a divided by b. Okay, and so if it is not divisible more, okay, listen, if a modulus division of b is so not possible, then it will return 0. Okay, this is a corrected code. Okay, see, actually we should write this code, so already I written this code and kept here. Okay, simple one. We should complete this code actually, so we already designed this one. Okay, fine. Next, let us move on to the next one more now. One minute. Read that problem statement, my everyone. The function int get range value accepts an integer n, okay, and is supposed to return a range value. Okay, if n is between 1 and 5, so then range value is 1. If n is between 6 and 10, so then range value is 2. For all other values, return range value -1. Okay, already code is given, so just we need to correct the errors. Okay, so observe, this is from switch case. This is from switch case. So here break is not required. If we returning this one, okay, so it transfer control from one part to the another part, right? Okay, at that time break is not required here. Okay, so although if you kept so there is no problem, but it is not required, no need of break. Okay, so fine. Next of all, return itself, return transfer control from one part to another part, right? Okay, so it won't execute so this switch block next cases. Okay, simply. Next, apart from this, any more errors more in this switch case? No errors? 1 minute, let me check this code. Okay, so by typing and executing, let me type and execute this one. Okay, to check whether any errors are present or not. Observe. So here in main function itself, so I will take code. Okay, so observe now. N, so scanf %d ampersand n. Okay, yes. Next, so switch n, so case 1 we are having like this, right? Case 1 to 5. Okay, so observe now. Return we are having, let us take so printf. Okay, printf %d 1, and so break. Now let us take break, guys. Okay, so now let us do case this one, 6 to 10. Okay, printf %d 2, right? And so break it. Next case default, I think so, for remaining so inputs more. Okay, so other than 1 to 5, other than 6 to 10. Okay, so for remaining values, so we should print so -1. Okay, that's good. Next, so break it. Okay, for last default break is not required, as I'm taking here. Observe, what is error? Too many decimal points in number. Is it correct, ma? No, we should not take like this. Okay, how we can take then? Can anyone give logic for this? How we can take like this? Very good, ma. Case 1, case 2, case 3, case 4, case 5. Okay, very good. We should take like this. Okay, so then it will so execute. Okay, yes, observe. So case 6, case 7, case 8, case 9, case 10, last one. Okay, yes, now observe output everyone. Now it will execute. Okay, you won't get any problem. Let us pick some random value. Okay, so 3, so 1, it is returning 1. Okay, now you can check more, so whether it is giving so correct one or not. Okay, what more ID number? So 478, and we write like this: n greater than or is equals to 1. So and this one n less than or is equals to 15, means you are talking about this one expressions, right? Okay, fine. Observe. N greater than or is equals to 1, n less than or is equals to 5. Okay, so observe, n cannot appear in a constant expression. Okay, variable expressions are not allowed, only number expressions are allowed. Okay, this is the rule of so switch case. Okay, we are having totally 14 rules. Okay, so in that 14 rules, so here you are observing this one. Okay, one of the rule. Yes, number only allowed. Okay, yes, so I hope so I understood this one. Okay, simply you should so take like this. Okay, so case 1 to 5, case 6 to 10, so like this. Okay, yes, for what my output I showed you output, right? For what, if you take like that ma, case 1, case 2, case 3, like that, if you'll get output. Okay, okay, fine, definitely I'll show you output. Observe, let us take this value 7. Okay, let us pick some random value. Observe, 7. Okay, okay, fine. Observe next problem. So this one is from arithmetic progression and geometric progression. Okay, next one is from arithmetic progression and next to that geometric progression. Okay, so here this function print series takes 4 arguments ma, s, d, t, c, h. Okay, so accepts integer s as the starting term of series, integer d as the common difference for arithmetic progression or else common ratio for geometric progression, integer t as the number of terms, and a character ch as the series type to print. Okay, it is supposed to print the arithmetic progression if the character ch is a. If character is a, we should print arithmetic progression, and the print the geometric progression if the character is so g. Okay, so that is the program, guys. Okay, yes, observe now. For us, so function is given, guys, the like this. Okay, print series, so s, d, t, c, h. So now we should fill this code. Okay, so before to this you should know about so this one. Okay, arithmetic progression and next to that geometric progression. Listen, So might be you know about so arithmetic progression and geometric progression. So yes ma, you can make use of formulas ma. Okay, so there's formulas only I'll use here. Let us take some series guys. Okay, 2 5 8 11 14. Let us take this one. So what is difference? So common difference in this one ma, common difference in this one is 3, right? Okay, so now observe guys. So let us take so like this guys, so formula for this one. So the same thing, so we can convert like this. Okay, so actually here you are observing some starting value, that is 2, right? So start value is some 2 here. Okay, so for different programs so different will starting value will be there guys. Okay, so for this one we are observing start value 2 and common difference 3. Okay, by observing this pattern, so for this pattern we are retrieving these. Okay, common difference, start value and all these. Okay, that's good. And so what you should find one next of all, how many values are there in this one? So total values, so 5. Okay, so we should find so this one, very good. Del given logic here, arithmetic progression, so a plus so n into d. Okay, so for geometric, this is for arithmetic progression. For geometric progression, so a into r so power n. Okay, that's good. So let us see all these afterwards more. Okay, listen. So how we'll get this one? Arithmetic for arithmetic progression, how we'll get this one? Observe guys. Okay, so first of all, so we take like this guys. Okay, a1, so a value. Let us take so first term guys. Okay, so term 1. What is term 1? We are getting 2. So what is term 2? We are getting so 5, right? How we are getting this? So 5. Observe guys, everyone. So start value we are taking. Okay, so start value, and next of all, so this one guys. Okay, the difference between so these two, what is the second value, right? This is so 2 minus so 1. Okay, so this one so we are multiplying with so common difference here. Okay, uh difference. So now observe, s value is what? So 2, right? Okay, s plus so 1 into common difference is so 3. So you'll get this one. Okay, next of all, let us take so next another term guys, you can understand very easy. S plus so 3 minus 1 now. Okay, so for third term, so next what you'll get, so into d. So s value is 2 as usually. Now here you'll get so 2 into 3. Okay, so you'll get 6, right? 6 plus 2, you'll get 8. Okay, I hope so you understood how we are getting this one. Now in place of this so we are substituting n more. Okay, that's it. Okay, so in place of these values, okay, we are substituting n here. That's it. And next, so formula for this one, the geometric progression. Okay, so I will show you so one example for this one. 2 4 let us take this one, 8 16. Okay, so what is the common so square difference of these? So 4 2 square 4. Okay, so next of all this one. Yes, very good. Now see here you are observing so this one, right? Each and every time so power is incrementing by 1. So let us take start value 2 more. Okay, so initially we take so start value is 2. Okay, so we take so this one r value, so power of so this one 2 into 1 to the power of first term. For first term we take r value 1. Okay, so 1 to the power of 1, what will get? So like this one, 2 to the power of 1 to the power of 1. Okay, what will get? 2. Okay, next of all 2 into, so next of all 2 square, what will get? 2 square 4. Okay, 1 minute more. So we take like this, sorry, 1 minus so 0. First of all, for the first one you'll take so 1 minus 1. Next of all 2 minus 1. Okay, So we take expression like this, not r power n, it is n minus 1. 1 minute, I'll explain. So 2 power 2 minus 1, what will get, guys? So for this one, 2 power 1, 2 into 2 power 1, what will get? So 4. Next, so 2 into 2 cube minus 1, 3 minus 1, this is in power actually. 3 minus 1 is power, in power. 3 minus 1 means you'll get 2, right? Okay, like this. If you take like this, you can easily understand. Observe. So 2 square, so sorry, 2 into 2 power 3 minus 1, 2. 2 square, 4. 4 into 2, 8. Okay, observe whether we are getting this series or not. 2, 4, 8. Okay, so how we are getting more? We are taking so starting value here into the multiplication, and next of all, so we are incrementing this r value more. Okay, see, see here we are taking r value fixed. Okay, r value fixed. So but so this value is changing, guys. Okay, so n value is changing. So 1 to 2, 3, all these. Okay, so here also you observed that so n value was changed. Okay, each and every time. So d and so s value you observe fixed. Here also you are observing a and r value was fixed, n value is changing here. Okay, so now let us see. So program, guys, we have formulas right with us. Okay, so for these two, so let us finish so programs, guys, for these two. Okay, so what are the values? Int s, and next to that int d, and so int t we should take, right? Okay, and the next of all, so char, so ch we should take. Okay, right. If we take a, so we should perform arithmetic progression. So if we take character g, we should perform geometric progression, right? Okay, listen. So scanf percentage d percentage d percentage d. Okay, ampersand s starting term. Okay, so d for difference. Okay, ampersand d, and so t for a number of terms. Okay, yes. Next, so let us take so input for this one, guys. Let's take here itself percentage c percentile ampersand ch. Okay, next of all, let us call that pattern, guys. Okay, print ampersand s. Okay, okay, sorry, comma, print, so series, let us pause, yes, dtch. Okay, listen, void print series int s int d int t char ch. Okay, fine. So now we should check this thing, right? First of all, so if character so ch is this one a, okay, so we should apply geometric progression. Else if so this one ch is equals to so geometric progression, so then we should apply, so if ch is equals to g, so then we should apply geometric progression. So we need the same three variables, right? Okay, so for calculating arithmetic progression and geometric progression, observe everyone. Okay, first of all, let us see so geometric progression. Okay, you know this one, right? So calculating power of a number without using inbuilt function. I am including inbuilt function here. Okay, so but you people don't include inbuilt function. Okay, So for easily completing, so code here I'm including. Okay, so already explained how to calculate this one. You can use inbuilt function, or else take some base variable value to 1. So simply multiply with so row. So here some this variable, guys. Okay, so that is d variable or else some variable. We should keep on multiply. Okay, that's it. As observer. We should so print a number of terms, right? Okay, for I is equals to, let us so take this one, guys, int I. Okay, so for I is equals to 0, I less than so t, I plus plus. Okay, very good. Here already, so one of the member given logic, very good. So what is so we should take some, right? Here s is equals to 0. Okay, s is equals to uh arithmetic progression we are observing, right? Okay, fine. S plus so instead of n you should take this one, guys. Okay, I think so, not so t into d mo. 1 minute. What we observed in the so notepad screen. Wait, let me check that one once again. This one, right? What you observed, so 1 2 like this, right? First of all, it will take 0 mo. Okay, wait, you should take so not n minus 1 mo. Okay, see here n variable is not there in our program. So instead of n we are having some other variable. Let us take this one. Initially it will multiplies like this. So 0 value will be multiplied so with this common difference. So that's why we got 2. Okay, first of all this 0 value multiplies with so this 3 here, common difference. This is start value, this is common difference. Okay, so here middle position, so here you are observing these values, right? So 0 1 2. Okay, so for this what you should take, guys? So s is equals to s plus listen, s is equals to s plus so I into so common difference t. Okay, and so next of all, so go for printing that one. Printf percentage d space so s value. Okay, that's it. Understood? I think so it will give the correct answer. If we get any problem, let us check. No problem. Okay, that's good. So this is arithmetic progression. Okay, so now let us see geometric progression. Okay, so for geometric progression also we should so traverse, right? Okay, observe int I variable, and let us take some temporary variable for storing result. Okay, for I is equals to recently it is given in Accenture drive, guys. Okay, so important one more, arithmetic progression and geometric progression for drives. Okay, so less than t I plus plus. Okay, good. So observe now into some temporary variable. Let us take result, guys. What is the formula we observed? So starting value into let us make use of this one, power function. Okay, so within this power function we should take so this common difference value, that is d, and next to that I, guys. Okay, so d and next to that I, common difference value is fixed, right? Okay, so into this d variable let us take this value. Okay, you observed r variable, right, in the formula. Look here. Listen here, we take an r variable, right? Okay, so that r variable value, so we are taking here in place of so d, this one d, that's it. Okay, that's good. Observe now. Where I taken r is equals to 2 more, 2 is equals to 2. I taken this one, I taken this series. So in that series starting value is a. Okay, this one geometric progression. So a value is 2, and why I taken so this one means here you are observing 2 cube format, right? Well, listen, 2 power 1, 2 square, 2 cube, in this format you are observing. Okay, that's why we taken base value 2 ma. That's it. R value 2 ma. R value is 2 here. This value changes ma. Okay, this value changes. Okay, so here we take 1 minus 1 means what you'll get ma? 0. Okay, 2 minus 1 means you'll get 1. 3 minus 1 means you'll get 2. What is this? Loop variable value. This is starting value. We are going to take into S variable now. Okay, A value we are taking A variable. In place of A variable we are taking S ma. Okay, in place of R variable we are taking D simply. Okay, S. So fine. Next, so afterwards, so we should go for so printing this one, right? So printf percentage D, so space so temp, guys. Okay, that's good. Now observe everyone now output for this one. First of all, let us see geometric progression. Okay, so let us take S value as 2. Okay, D value as 2, and so this one T value as 4. Okay, okay, fine. So we taken S value 0, right? Okay, already we taken same variable. Okay ma, fine, let us take some other variable, sum. Okay, good ma, thank you. So thank you. Okay, mm, mm, or else let us do one thing. So first of all, let us print so S value. Okay, so afterwards let us update the S value. Okay, so that it will be good, right? In shell, let us take so this one, guys. S variable, let us take it into some variable. Okay, and so let us take so this one SS ma, sum is equals to sum into I SS. I to understood this. 1 minute. What I should do now? So this one we should go for printing earlier then. Okay, so first of all we should print this one, otherwise we get so this right. First of all it will print so 2 now. Okay, so what is the series we taken? Think so 2 5 8, I think so we taken, right? So it will print 2. So next of all what happens more? Arithmetic progression, right? It is 1 minute. Okay, fine. One minute more. Wait. So 2 some value increments to 2 plus so what is I value? So 0 into, so first of all the common difference of this one is, let us take this series, guys. 2 5 8. Okay, we should print this one. The common difference of this is 3. 0 into 3 you'll get 0. Okay, you'll get 2 here. Okay, next of all you'll get so 2 only, right? 1 minute more. So here if we remove this one, 2 plus 3 you'll get 5. Okay, and so next of all it will goes for printing 5. Okay, next of all, so 5 plus so 3 8. Yes, you'll get like this. Okay, so we interchange it, we changed that formula here simply. Okay, see here we simply adding with the common difference ma. If you simply add with common difference, arithmetic progression means what ma? So nothing but addition, right? Okay, geometric progression means multiplication. Okay, so that is the thing. So here with the arithmetic progression we are adding now, okay, with the common difference 2 plus 3, 5 plus 3, all these. Okay, so you'll get so result here. So sum is equals to sum plus d. Okay, so fine, you'll get so answer here. You can take like this, I think. So extra variable is also not required now. 1 minute. Yes, s is equals to s plus d. Okay, actually there we observed so s is equals to s plus nd. Okay, in place of that we are taking this one, s is equals to s plus d. That's it. Okay, observe output now first of all. 1 minute. Int s comma, okay, sorry, here declaration. Observe output my everyone. Let us take so first of all this one. Okay, what we taken now? 1 minute, sorry, I forgot now. 1 minute, let me see this one. S dt, s dt, right? 1 minute. Once again I'll execute it. SDT afterwards character. Okay, what is the starting term? So in arithmetic progression 2. Okay, what is common difference? 3. Okay, let us print some so 10 terms, guys. Okay, yes, we are not getting output. 1 minute. Sorry, we forgot this one, right? 1 minute. Entering character. So 2, 5, 10. So let us enter so character YEMA. Okay, arithmetic progression. Yes, once again we are not getting. 1 minute. Let me check. Here sometimes we get problem regarding this one also now because of entering character at the end. Okay, so 1 minute, let me check this. So character a 2, so 3, so 10. Yes, see, do you observe this one? See, actually character should be allowed in the starting only. Okay, after entering the integers, so it is not allowed to take at the ending. Okay, so we are getting arithmetic progression here. Okay, the common difference, so starting value is 2. Okay, common difference of these is so 3, and the next of all so this one. How many values we are printing here? 10. Okay, yes, and next of all let us see geometric progression now. Here in the C++ compiler, it is not allowed now. Okay, first of all we should take character only, afterwards we should take integers. Might be in remaining compilers it is allowed. Okay, so fine. Observe output now for geometric progression. So G, so starting value in geometric progression, let us take so 2, and so common difference, so that is R value, guys. Okay, we should take powers so in the form of 2's, right? Okay, so a start value 2, so powers also for power we should take base 2. Okay, and how many values we should print? Let us so print some 10 values. Okay, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. Okay, yes, 2 is the starting value, okay, and 2 is the second 2 is R value. Okay, so that is base value, and so next of all 10 is the number of series values. Okay, so arithmetic progression means simple addition, geometric progression means multiplication. Okay, that's it. So these programs are important so for drives more. Okay, so I will give you this one, have this code everyone. So all of you observe code once again, no? If you are having any doubts regarding this, you can ask. Okay. Yes, ma, definitely ID number 546. So we'll send ma. Okay. So already I think so. Yesterday PDF I sent. So to sir actually, so concerned sir. So sir said that so he will post on so this one Instagram group. So today also I will do the same thing, ma. I will forward this document to sir. Okay, sir will post it in the Telegram group, ma. Okay. So I will intimate to sir at once in today's session also after completion of today's session. Okay. Don't worry about this one. ID number 546. Okay, ma. Okay, fine. Thank you, ma. Thank you. Yes, good. I hope so everyone understood this. Ma, simple it is addition, ma. Arithmetic means simple addition. Okay. Geometric progression means power program. You know this one, multiplication and power. Okay. So it is not all matter, ma. Next, let us move on to the next one, ma. See, here we should print this rectangular pattern, ma. Okay. But in this rectangular pattern, rectangular or else square. So rectangle pattern only. Yes. In this rectangle pattern, ma, do you observe these values? Last but one column, okay, last but one row, okay, last but one column, okay, and next of all not in first row, and next to that not in first so last row, okay, only so in between first row and last row, okay, so in between these rows only in the last but one column we should print so values like this, guys. Okay, so 1 2 3, Mari observing this 1 2 3. This is normal rectangular pattern only. So but here one small twist is there, okay, in this one. So that is we should print like this. Can you print this code? So I will show you one more output specification. Okay, so observe everyone, 10 rows 10 columns. So this is square pattern. Might be they may ask you square pattern like this. Here you are observing 5 is the input value, 6 is the so number of so columns. Okay, 6 number is related to the number of columns. 5 rows and 6 columns. Okay, fine. 5 rows and 6 columns now. Actually, we should take input as number of rows and columns, and we should print the pattern, guys. That's it. Here, are you observing this? 1, 2, 3, 4, 5, 6, 7, 8. Okay. My last but one column values, so we should print in different format. So can you give me code for this one? Right, everyone. We have 11 columns including first line. 6, no ma, 10 columns only. I think so. 3, 6, 9, 10 only. 10 only, ma. 208. Not 11. This is interesting pattern, right? So it is interesting one, ma. Last but one column, okay? And not last row and first row, ma. Okay? In my words itself, logic lies, ma. Okay? In my words itself, logic lies. Last but one column, okay? Not first row and last row, ma. Okay? You all know square pattern. So you observed so 2 for loops for rows and columns. So many times you observed. That is not all matter. Okay, and observe how we should print these values. Okay, you can finish it off within 5 minutes more. Okay, it is not all matter. Okay, fine, I will show you. So code for this one. So how many values we should take input, guys? So rows and next of all columns, right? Rows and columns. Okay, rows, columns. So we should pass rows and columns to so print pattern function. Okay, that's good. Now let us see this one, guys. Void print so pattern, so int rows, int columns. Okay, simply what you are observing there. Listen, once again I will share that screen, okay, to you people. Now what values we are printing in the rest of the rows and columns? Now, can you tell me that one first of all? So what we are printing here? So 5. Leave this one, last but one column. In remaining positions, what we are printing? 5. What is this 5 here? What is this 5? Row, right? It is 5 is row number, right? In the remaining locations, we should print row number. Thank you, ma. ID number 563. So good. In the remaining locations, we should print so row number, okay, except in the last but one column. Okay, here also you can observe we are printing 10. 10 is row number, ma. Here column number and row number is same. So but we should print row number only, ma. Okay, because you observed an input one specification, right? In this input one specification, you can observe what we are printing. We are not printing column number, ma. We are printing row number. Okay, yes, I think so you understood this. Now let us move on to the coding, guys. Okay, yes, so observe. So simply you are observing like this, okay, the pattern 5 5 5 5 5. Let us take like this 5 5 5 5 1 5 5 5 5 2 5 5 5 5 3 5. Okay, and so this one 5 5 5 5 5. Now from actually in last but one column, what you are observing? So in each and in two input output specifications, you observe this thing. Okay, so printing values from 1 1 2 3. What is this? This is nothing but count, right? Okay, so in these so last but one column positions, we should start printing from 1. So 1, guys. Okay, that's why here I am taking so count variable value 1. Okay, yes. So now let us take so two loops, guys. Okay, for let us take two variables I and j. Okay, I is equals to so 0, I less than so r. Let us take r more. Okay, I is equals to 1 and I is equals to m. Print m. Else if j is equals to n minus 1, last but one column. Oh, then what about so this one? Del observe. You given logic. Okay, good try. So but last but one column means so what about these positions? What about these positions? If I is equals to 1 and I is equals to m, okay, you are saying that so it will print m. Okay, so else if so j double is equals to n minus 1. Okay, so j double is equals to n minus 1 means so by the time it will consider that one also, right? Okay, so observe here I will execute your code only. Observe your code only I will execute. Check it. For j is equals to 0, if we get output, no problem. So we should check so in detail, right? I didn't check it directly, so I am considering that it won't execute correct output. Okay, it won't gives you correct output. If it gives you, no problem. So fine, observe if I double is equals to 1, okay, and so I double is equals to r. Okay, I double is equals to 1 means here 0, right? Okay, here it is r minus 1. Okay, so printf percentage d, so row number. Okay, row value we should print. So else if here I am executing her code, all of you listen now. Afterwards if we do not get output for this so I will show you some other code, no problem. So printf, so percentage d, so not jma, let us take this one, count plus plus. Okay, let us take this one, or else you taken j variable, right? So let us take that one only, no problem. Okay, and so outside of this, let us take a backslash n. Okay, up the output, my everyone. N not declared. Okay, fine. So column, right? C minus 1. Up the output, ma. Let us take so 5 row number, 6 columns. Okay. So we are not getting output, ma. First of all, listen. Observe here. We are getting output like this. See, you should follow some procedure, ma. If you follow that procedure, you can easily complete it, guys. Okay. I will show you that procedure. Observe everyone now. So you think correctly. So, but you mistaken somewhere else. Okay. Listen. What I said. First of all, focus on this one. Okay. So these values. Okay. After focusing on this one, in remaining locations, you can easily print. So this one, guys, printing value 5 is not at all matter. Okay. So printing values 1, 2, 3 is matter here. Okay. So where you are observing here, first of all, I told you this one only. Okay. Last but one column and not in first row and last row. I said in my words itself logic lies. Okay. Observe. I am typing the same thing now. If I not is equals to 0, I not is equals to 0, I not is equals to, I not is equals to, so row minus 1. Okay. I not is equals to row minus 1. If it is true, and so we should check one more thing, guys. Okay. So for printing so these values, 1, 2, 3, and so for printing these values I am writing conditions there. Okay, so if we are not in the first row and the last row, okay, and if we are in the last but one column now, okay, now if you include this condition, program will be finished. Okay, so if we are not in the first row and the last row, and so if we are in the last but one column like this, okay, j double is equals to c minus 2, j double is equals to c minus 2. If we are not in the first row and last row, and if we are in the last but one column, so by that time you should print like this, guys. Okay, so printf percentage d, so count plus plus. Okay, count, so plus plus. Next, afterwards what you should do, see here, I naught is equals to 0, I naught is equals to r minus 1 means, so it will goes for so second row, third row, fourth row. Okay, so all these 3 rows moves into this if block. Okay, in all these 3 rows, so we should print values 5s, right? In the remaining locations, in the remaining locations we should print so these 5s, right? Okay, so that's why here I am adding one else block. Okay, here I am adding one else block. In this else block I am printing so r value. Okay, I am printing r value here. And next, so if we are in so first row and next to that last row, so here so for second row and third row it will print 5s. Okay, second row and third row, fourth row it will print 5s. Okay, so what about first row and last row? For first row and last row we should print so row value, right? Observe now. For this one also we should take one more else block. Okay, if I is in 0th row, if I is in last row, okay, so by that time we should print so this one, guys. Okay, row value once again. That's it. Are we doing so are we keeping any effort? Simply we are completing. Okay, so if we are in so first row and last, if we are not in first row and last row, and if we are in last but one column, we print this one. Okay, and so if we are in not last but one column, and in the remaining columns of so second row, third row, and fourth row, okay, we are printing row values. And so this else block we are taking for so this one, guys. If we are in I row, first row and last row, okay, so by the time printing so row variable value we are taking this simply. That's it. Yes, I hope everyone understood this one. Okay, I will give you this code. I will paste it in the chat box. Have it. Okay, so check everyone and observe output my everyone now. Observe output, guys. Last means R or R minus 1. No, R minus 1 row value 5. Here we are taking from 0 row. We are taking from 0, right? That's why we are taking R minus 1. If we take so loop from 1 means so we consider R is lost. Understood my ID number D not? Based on so taking so I variable and loop variable values, we decide this one R minus 1 and R, C minus 1 and C. Okay. Okay, ma. Thank you. Yes, ma. Definitely you can take. So like this also. So there is no problem in it. So just I extended that one to clearly understood. If I keep number of conditions within single if itself, okay. So you feel that it is complex, right? That's why I splitted that one. Okay. So if you want, so like that also you can take it, guys. Okay. Listen, ma. See here, one of the student asked this one. Okay. If I is not is equals to 0, listen, ma. This condition directly we can take in this one. And so this one, so then by the time it will goes for printing this. Okay, by the time we can so reduce the code actually for readability purpose. Okay, so here few members cannot understood, right? So for that purpose I taken this. Okay, yes, I hope they understood. Now listen, observe this one. I'll execute this one, you'll get the correct output. Okay, else so without a previous if 1 minute more. Okay, I understood. Yes, I'm taking, I'm updating here. Observe output, my everyone. Let us take this one 10 and 10 now. Okay, observe output, everyone. I think so it is clumsy, right? 1 minute. So let us give some spaces. Okay, if we give spaces, so then for you people it is clearly visible, guys. Okay, so print so percentage space. So here also print so percentage space. Okay, 10 and so 10, guys. Okay, observe. I hope so it is visible for each and everyone. So check more output. Um, is good. I hope so everyone understood this. I will so paste this code also. Okay, so have it, guys. Simple one more. So simple, if in this condition we should print so count variable. Okay, so in remaining locations we should print the row variable value. That's it. Okay, so you can easily finish it out. That's good. Next. What is time now? 8. Okay, so just 15 minutes left more. Okay, So observe everyone, the next one. We should take the last iteration separately. Outside of the loop, we should take separately. Okay. Uh, we should take separately. That's it. ID number 52. So we cannot do anything. The last iteration, for last iteration, you should write so code separately. That's it. So we cannot do so in any way. Okay, fine. So observe, read this program. Print full number. They accepts unit digit and 10th digit. Okay, number. Okay, so where 10th digit is missing, unit digit and 10th digit as input. Okay, function is supposed to print the original number. Okay, observe. So observe input specification, everyone. So 5 is the given number, okay. 6 is the units place, 7 is the tens place. Okay, so you should form number, okay, with that. So that is the program, simple. So you can easily finish it off. I think so you can easily give code for this one. Observe here, my code is not given, so we should complete the code for this one. So by making use of these variables, unit digit, 10th digit and number, so you should also complete the code. Okay. First of all, let us take so number as 5. Okay, number is 5. So unit digit is so 6, and next to that so 10th digit is 7. Okay, let us take these digits. Okay, now we should print so 576. Okay, for this one we should print so 576. What you should do, first of all, this 5, so you should multiply with so this one, right? 5 should be multiplied with 10. Afterwards, the 10th digit should be added. Okay, so what you'll get, so you'll get 57. Okay, next of all that so 57, so on multiplying so with this one, guys, 10, and adding with so units digit 6. Okay, so you will get so 576 more. Okay, I hope so you understood how you will get this one. My number is there, right? N is equals to n into 10 plus 7. Okay, here I am giving code for this one, only 2 lines required. Observe. So next of all, so we get some 57 value right into this one n variable. We get this one 57. So now what you should do, you should take one more expression, so that is this one more, n into 10 plus unit digit. Okay, earlier we taken so 10th digit here, earlier we taken 10th digit, so now we should take so units digit, guys. Okay, so that program will be finished. Okay, simple one. Is not all matter. Okay, yes, observe the next one. I think so for this one also we should write so code. So this is triangular pattern, so but we are not having enough time. Slip count. Okay, so go for so making corrections more for this one. Here so flip count is accepting 2 integers. Okay, a and b as a input. The function returns the flip count is the number of bits to be changed in integer a to become integer b. Read this one. It takes 2 variables as input. The function returns the flip count, that is the number of bits to be changed in integer a to become integer b. Okay, on changing how many bits in integer a, so that it will become integer b. So we should so check that one, guys. Okay, means simply we should check different bits. Okay, Earlier we counted, so same bits, right? Now we should count so different bits ma. That's it. Okay, ma, listen. So for 5 you'll get 101. Okay, so for 6 you'll get so this one 110. Okay, so how many bits are not common ma? 101. We should change these two, and so we should change these two. Okay, so means totally we should change the 2 bits ma. Okay, in these two values. Okay, the same thing you are observing here. Yes, observe ma. Observe code for this one. Let us take so 5 into 5 exclusive or of 6, whether it is working correctly or not. Now what is the result of this one? 5 exclusive or of 6. Apply like this. So 101 and so 110. Okay, so which bits are, if bits are common, so then you'll get result 0, right? Okay, so here for this one you'll get so 01 means 1. Okay, 10 means you'll get 1. Okay, so what is this value ma? Now what is this value? 3. Very good. ID number 285. You will get result 3 ma. 5 exclusive or of 6, not 2. Okay, on applying 5 exclusive or of 6 you will get 3. So next so count takes 1. Okay, so this type of thing so we observed guys, if you take count 1 you'll get so incorrect answer. Okay, we should take count value from 0. Let us see that one afterwards. Okay, so now observe ma. Bits less than 0, 3 less than 0. Okay, maybe for different values you'll get different answers ma. ID number 208. So for this one you'll get 3 ma. Okay, that's good. Now observe ma. Bits ampersand 1. So what is bits value? 3. Okay, 3 ampersand 1 means what you should do ma? Again you should take so binary form of these two. So 3 already there here. Okay, so now let us take so 1 in binary form. Okay, so 0 1, sorry, 0 0 1. Okay, so what is result for this one ma? Only these two bits are set to 1, right? Okay, you'll get 1. 3 ampersand 1 ma. 3 ampersand 1 means 1. Okay, ma. 3 ampersand 1 means 1, not 2. Yes ma, I will explain. 254. So that is mistake ma actually. So 3 less than 0, that will gives you false, right? Okay, so here concentrate on this one ma. 3 less than, 3 greater than 0 you should take. Okay, here you should update this counter value ma. Counter value you should take 0, and so we should take greater than expression, not less than. Okay, so fine. So tell me answer for this one. 3 ampersand 1. For this you'll get 1, right? This count value will be, so count value will becomes 1 right now. Okay, afterwards we are having modulus division expression. Okay, listen, 3 modulus division of 2, what you'll get? So 2. 3 modulus division of 2 you'll get so 1. So now 1 less than 0, 1 and 1, so you will get so 2 here. Okay, 1 greater than 0, right? Next of all, so 1 greater than 0, so this one will gives you true now. Okay, so what happens now? So bits value is 1. Okay, 1 ampersand 1 means you will get so true, you will get 1, so that count value 1 will be added. Okay, so to this one, so fine. Okay, good. So these corrections we should make guys. Okay, for this one, count value should be initialized with 0, bits greater than 0. Okay, we should take this one. Okay, that's it. Next one, observe. So for next one we should write program, a simple program it is. Okay, Here already some function is given, okay. So with some function calculation is done. So that is the common values of three arrays. Observe. Common values sum program. This is what are common values in this sum. Observe. I will explain this program directly. Observe. Common values in array 1, array 2, array 3, 4 and 6, right? Okay. So if common values so sum is even, okay, 10 is even, right? If it is even, directly we should print so this value, guys. Okay. For suppose observe second input, guys. What are common values in this? 1 2 4, 1 2 4, 1 2 4. Okay. So what is sum of this one, ma? 1 2 4 values. So tell me 7, right? So if we got so odd value sum, if we got odd value sum, so then what we should do, ma? We should multiply that one with 7, ma, simply. Okay. So that value, so 14, we should return from that function. Okay. So from the function, that is the code, guys. Okay. Simple one. So if we got a result in the form of even, so directly we should return, guys. Okay. It is not required to do anything. So if we got result in the form of odd, so we should multiply with the 2 and we should return the value. Okay. Observe code ma now, everyone. See ma, already sum is calculated ma. It is not required to write this function, sum of common elements. Okay. So here we get result into this temporary variable ma. You should check. So whether we got sum even or else odd. Okay. So like this, with the help of if ma, with the help of if, we should check. So whether temp value is modulus division of, so 2, temp value is even or not. Okay, we should check like this with the help of this condition. If it is so even, so then directly we should return, so directly we should return so temp, guys. Okay. If it is not, if it is odd, so in the else block, so you should return like this, guys. Okay, you should return, or else I think so we should print. Okay, we should print here itself. Okay, if even common sum is written set as well. So if we got odd sum, okay, so odd sum as sum of common elements of these three arrays. Okay, at that time so we should print so this one, guys. So 2 into temp. Okay, that's it, simple one more. Simple program. I hope so you understood this one. Okay. So that's it, ma. Still we are left over with some more MCQs, ma. 4 6 common, they return 10. Yes, ma. 4 6 is common, so those values are so added, and next to that so printed, ma. Okay. And next of all, in the second input you observed 1 2 4 is common, right, in 3 arrays. Okay, those the values are so added, we got 7. Okay, 7 is odd, right? So that's why if you got odd, so you should multiply with 2, ma. Okay, that is the problem statement. So I will send you the remaining coding questions also, ma. Okay, so you try it, you practice it. So already I given answers also in this one, you can easily finish it. Okay, so all the best for the drive, ma. Okay, so good luck for you people, so crack it. So with patience, so check everything, okay, again and again. Okay, don't give up, ma. Give tough fight. Okay, so all the best. So go ahead, guys. Okay, yes, let us meet so some other time once again. Okay, if possible. Thank you everyone. Thank you, ma. PDF definitely I will post, I will send to Sarma. Okay, Sar will post you in the Telegram. Okay, so there is no problem. Okay, fine. Thank you everyone.